I guess the first thing to say is preparation, always important. I've been teaching for 15 years. Maybe after teaching 16 years, I will reach a point where I'm like, I don't need to prepare anything, right? I somewhat doubt that. And part of the reason why is because being able to, say for example, here's a phrase for you. It's out of a book that I'm reading right now. Being able to orchestrate a productive mathematical discussion across 30 different students. That takes time and care and thought, even for a concept I know backwards and forwards, and I've taught it many, many times, but I've never taught it to this class before. One of the funny things that will happen in your first few years is you'll teach, say for example, in your first year, I had a year 7, 8, 9, 10, and 11 class, and I shared them with another teacher, right? And I was like, great, I got to the end of the year, I've survived, and then the second year, I was like, oh, I've got year 9 again. I've taught this before, this should be great, right? And I rolled out some of the plans that I put in place and some of the activities I tried out, and they just sank like a lead balloon. I was like, what happened? This lesson went great last year, right? And the answer is the class was totally different. There was a different dynamic there, right? And so this preparation part of things, how do I prepare? Well, just like you, I start with the syllabus, and you know, it's really interesting to me. We're staring down the barrel of 2024 is the new implementation of a year 3 to 10 syllabus, right? And even though we are secondary educators, we build on what's happened in years, you know, all the way from kindy and so on, right? So knowing the whole continuum is very important. So I go to the syllabus. I want to understand, why are these dot points here? Why are they arranged in the way that they are? How are they connected to other things? Because you want to think about, we call it foundational knowledge, what am I built on? And then horizontal knowledge, where are students going to go from here to somewhere else, right? Like say for example, I remember in year 7, I taught this for years without realizing where it was going. Do you remember you have to teach about different kinds of fractions and how they relate to decimals, right? So for example, there are these things called terminating decimals, and certain fractions give you a terminating decimal. And then there's recurring decimals, and certain kinds of fractions give you that. And then there are, well, there's the irrational numbers that give you, like, they're real numbers, but there is no fraction for those, right? And that's why they just go on forever, like a weird jazz song that never repeats. Now, I didn't really have a deep understanding of why each of those fractions led to those kinds of decimals and how that goes into stage 5, surds and irrational numbers, and then how that goes again into, say for example, think about this, right? Do you remember recurring decimals? Really what they are is just an infinite geometric series, yeah? Because say 0.3 repeater is 3 over 10 plus 3 over 100 plus 3 over 1,000, etc. So it's, I just saw a light bulb go on, right? Don't worry, I didn't realize that until I taught it, right? Now, you can imagine, right, that obviously the first time you're teaching this, you don't have space in your brain to work out all that other stuff, but you want to start to build towards that. And it's actually one of the reasons why a huge advantage that you have as secondary teachers, that often our colleagues in primary, it's very hard for them to access this, is that you will teach like multiple years every year. That's a bit confusing to do, but it's also fantastic because you get exposed to where this goes, right? You'll encounter primary teachers who might teach year 1 for like 8 years to really master. Remember, they're not just doing one KLA, they're doing all 8 of them for 1 year. It's a lot to wrap your head around. And so they might not really know what happens in year 3 or year 4 because they've stayed in that space for a long way, or either way, right? So take advantage of knowing what those connections are, and then I think, what are the appropriate questions or activities which will help my students encounter what the syllabus dot point is about, where it's come from, where it's going. And then lastly, if you weren't at cognitive overload already, I want to think about the fact that every part of the syllabus, say for example, I was thinking about trigonometry this morning on my train in. Why do we care about trigonometry? It's really interesting, right? Spoilers, we don't care about trigonometry because any of our students are going to use it after they leave school. Even those students who are going to do something like engineering or architecture or physics, where trigonometry is something they have to do, they're going to get a computer to do it, right? They're never going to use the cosine rule or graph like 10x by hand. They're not going to do it, right? But we care about it. Trigonometry is fantastically useful because it's a theatre for learning communicating, understanding, problem solving, reasoning, fluency, and justification. Working mathematically, which I talked about a little bit in the seminar I had with you guys, that's the part we really care about. So after I've thought about the content and thought, yes, I've selected some examples, these are going to be good, these are the questions I'll have my students do, here's an activity, let's go outside and get the... You guys are too young for this, well, mostly they're too young for this, but when I went to school, there were these things called clinometers. Clinometers, they measure incline. So you would point it at something and it would tell you what the angle of elevation was, right? Now we don't really need these things now because we've got things like this, that it's like, okay, I can measure the angle like so, but use a different tool for the same purpose. Let's go and work out the height of the clock tower. I'm not going to go up there with a tape measure, right? But we can use trigonometry to do it. Okay, I've thought about all of that. I've got my examples, my questions, my activities, and then I weave that all together with working mathematically. So that's kind of the process that I go through when I'm planning and preparing a lesson.